welcome back. We have two case studies that will conclude the conference today. First, we have two speakers from the well-known UK contractor Kiltbray. Their technical manager, Dave Rowe, and project director, Jim O'Sullivan, will be talking about the demolition of Earl's Court Exhibition Centre in London. Dave has been with Kiltbray since 2003 and has worked on many of its most important projects. Jim O'Sullivan has 20 years in the industry and is the project director of Earl's Court project. Please welcome Dave Rowe and Jim O'Sullivan to the stage. Thank you.
We're here to present Earl's Court Demolition. Dave and I have been on the project for 2 years solid. Before that, Kiltbray, himself and Dave, 5 years pre-construction, designing, methodology, planning the works, etc.
Okay, so the scope of the works was for the demolition of Earl's Court 1, EC1 and Earl's Court 2 exhibition centres. Earl's Court 1, as you can see here, is a large reinforced concrete frame, 50,000 metres square on plan, and Earl's Court 2 here, 20,000 metres square on plan, and that's a large steel frame arch truss construction upon a transfer deck which spanned over the top of the West London line. To the top of the image here, you have what's known as Bridge 19. Very small it may look in the scale of this image, but as you'll see, quite an interesting part of the project. So we have divided the sort of scope up into a series of stages. Stage 1 was demolition of Earl's Court 1 down to the previous, or the exhibition floor here, and following that we then had to take it down to the basement slab level here. The reason we describe it separately is there are some additional challenges in taking this ground floor slab out, which we will come on to a little later. Concurrently with the demolition of Earl's Court 1 was the demolition of Earl's Court 2, this steel arch truss structure here. Underneath was the West London line, which is a network rail, major rail artery, operates 24 hours a day, 7 days a week. And also underneath was various London Underground sidings for maintenance, and it was also the original car park for the venue. So first we took that down to the transfer slab, again the previous exhibition floor, and then took the transfer deck out, leaving what's known as retained deck over the top of the operational West London line. So this is a massive rail infrastructure protection project. As you can see here, we had 4 district line tunnels which actually ran within the basement of Earl's Court 1 that had to be protected at all time. Millions of passengers a day running through the basement. Through the centre of the site, bisecting the site indeed, was the Network Rail West London line. To the north was the Lillie Bridge depot, where they carried out maintenance for the tube trains. The centre of the site also was the boundary between 2 local authorities, Kensington and Chelsea, and Hammersmith and Fulham. So that posed additional challenges in terms of approvals and planning, particularly with noise, dust and vibration management on site. And to top it all, we then were adjacent to about 600 or 700 residences on these 2 curves here around the perimeter of the site. So due to the challenges we have with Network Rail and London Underground, we had very, very stringent and rigorous processes to get through, but different processes with both bodies, and actually establishing what documentation would be required in order to be allowed to even commence the works. And that leads me on to the initial part of the project, which was the removal of Bridge 19. This is actually an extract from a presentation we delivered to the neighbours, as you can see here, back in November 2014. So the bridge you can see here was the major pedestrian and vehicular access between Earl's Court 1 here and Earl's Court 2. So you can see the bridge here, it's made of 2 spans. The secondary span here and then the major span over the top of the West London line, roughly 30 metres in total. And it was constructed of large primary beams that were steel beams, concrete encased, large parapet vertical protection on either side, with then secondary spanning beams with a metal decking over the top and then a concrete slab. And this is a picture during the construction, about 1989. You can see the formwork in place for the concrete encasement. So initially, when we were planning the project, this was to be the last demolition activity. So all of the other structures would be gone, and we were to use standard demolition techniques to remove the bridge. We'd agreed back in 2011 a 96-hour possession where the rail would be shut over Christmas to take this out. Unfortunately, due to the economic climate, the project went back, and it was impossible to renegotiate the possession, so the possession date never moved. Consequently, this became the first part of the demolition to be undertaken, and politically it was not seen as a good idea. The first thing anybody sees of this major scheme is huge and potentially loud demolition on Christmas Day. So an alternative solution was generated, whereby we would construct large skid beams, on top of which would be a gantry holding strand jacks. We could then sever the two spans, lift up on the strand jack gantry, and then slide across where the bridge spans could then be demolished after Christmas. So you can see here is an animation of the scheme that was to be installed, and it's analogous to a system that you would generally see for the installation of large systems on a petrochem type site, and then the systems the spans could then be driven away on SPMTs, self-propelled modular transporters. This is just a technical drawing showing some of the design. And one of the major issues we had with this was that we had a very compressed time frame to actually get this agreed with Network Rail due to the late change in the technique. So we had to get their buy-in that they would accept this methodology. It had tremendous benefits to them in terms of assurance on handing back the possession, handing back the track so that passenger trains and freight trains can run, can cost hundreds of £1,000s sort of a minute. So it's essential we hand it back on time. So we developed very detailed staging on each of the documents we would produce. And then here we carried out a risk analysis in the programme on an hour-by-hour basis, looking at each of the activities, identifying the worst-case overrun for each of those activities, and then various hold points so that we knew that if, for example, this one here, so long as we were within the worst-case duration, we could continue to the next activity. As well as that, we produced hour-by-hour programmes for the Christmas Day removal, and these are the time slices because we had to report back to Network Rail on an 8-hour shift basis. We were working 24 hours a day, so they could understand what they were expected to see and how well progress was going. So that was the plan, and now, with any luck, this is what actually happened. If you could.
Water.
So it's a 500-ton mobile crane brought in that was used to actually install some of these large lifting beams. So this steel gantry system was installed leading up to Christmas. The venue was still operational, so we still had various shows going on that we had to work in and around. Here you can see this is on Christmas Eve, removal of the first span, and then laid off onto SPMTs, which could be then driven away and then stowed off, ready for demolition in January. These are multi-axle vehicles. All the axles can be linked together to allow it to move as one system. One of the key aspects of this programme was it was designed such that the last piece of percussive braking occurred on Christmas Eve. So it was virtually silent for Christmas Day and Boxing Day when people would be enjoying their family holiday. So you can see now we're forming the final separation cuts. This is actually cleaning out the cut on the primary span. The final cut was a wire saw because it was directly over the track. And the final span to be removed was 500 ton single piece. So this is about 10 o'clock Christmas Day. And one of the key parts of this was that once this bridge span had been removed, had the projects have overrun slightly, we could have just stopped there and handed the track back. The gantry could have stayed in place. But the programme was such that if it did go according to plan, we could remove all of the gantry as well within the same possession, which is what you can see going on here. And then we're now carrying out traditional demolition of the support buttress structure. Trains then ran again over the Christmas period, and then we came back on the 3rd and 4th of January for a further possession for traditional demolition of the adjacent bay. You can just see here, this is the propping, so there's a huge amount of propping that had to go underneath the deck to take the SPMTs and the load of the 500 ton span.
Right, just to put that in perspective, that's that bit of the job, okay? So the rest of the site now is this part of the site here. These are the houses or the residential area Dave referred to on both sides here, and that's Kensington and Chelsea, which is quite a posh district of London. This side is Hammersmith and Fulham, not so posh, but still very important. So basically, we cocooned the whole buildings in scaffolding, protective sheeting. There's a one-way access, there's a one-way street Warwick Road here, and two-way access here, and access in here. So the building itself, it was finished in 1937. A large 4 to 5 story reinforced concrete frame, but they're very high stories for the main exhibitions. Reinforced concrete span, two-way spanning slabs. The structure was actually built, you can't see it at the moment, we'll come on to it, over the district line tunnels. The external walls were just infill brickwork, and there were some massive roof structures which had come on to demolition. So this gives you a plan of the actual, these are the district line tunnels. So these lighter blue here and here, there's 4 of them. And below it on this side here, there's 2 Piccadilly tube lines. This outline here is the main roof structure. So what we're trying to show you here is the relationship to the tunnels. So we had to demolish this roof structure whilst maintaining protection to the tunnels, all operational. Plan of the roof, these are what we call the small roofs. This is sort of 15 metres by 75, 15 by 60. The main roof, we call roof B, was 75 metres clear span by 125 metres long. So what we looked to do was basically reduce the actual trusses themselves by putting these temporary support towers in, and then we're going to lower the roof down to the exhibition floor. I like that slide. This is to give you a picture of it being constructed. This was a swimming pool in the centre of the site, and they built a large gantry crane, and they basically lifted all the steel sections up and riveted them together in situ. This is a view from the top, whilst the whole concrete frame structure is going on. Earl's Court 2 doesn't live here now. This is a view from inside the roof. Because it was an exhibition floor, or exhibition building, there was no light that came from the roof. So this is asbestos sheeting, chrysotile called Trafford sheeting, and these are the main trusses. So there's 7 main trusses. See the outline here. From the eaves to the ridge of the roof is 25 metres distance in height. So what they did, this was the Trafford sheeting put on originally. They came along 20 years later and decided to basically overclad it with steel cladding, and they just drilled straight through the old purlins here. So we had to remove all of that in a controlled manner. Picture again, this is the green highlights the areas of the roof that we had to dismantle, and below you can see the old tiers of the seating, which was part of the theatre or the concert hall. Below the structure, there was lots of parts of the structure projected into the space, which was below the truss. So we actually carried out demolition enabling works to clear the space so the trusses could actually lower down. To actually support the trusses, we designed a strand jack system. So this is a temporary cantilever to get the strand jack inside the actual footprint where we're going to cut. So this was then connected to the steel truss. This was all strengthened for the connection, and the strand jack connected to each end of the truss. So there's seven major trusses, so there's 14 strand jacks. So that again is very crudely the plan. This is how it actually happened, believe it or not. We keep that bird just for the sake of it. This is the roof. Now we had 3 tower cranes to actually give access to the main roofs. So this is taking the asbestos sheeting off. You can see the extent of it, and we did this by abseiling. I'll talk about EC2 later, or demolition. This is just to show you this, give you the size, so you can see the 2 buildings going at the same time. This is the EC2 structure. I'll get back to them. This building here is actually full of 2,000, 3,000 police people, which was another hindrance. This is the preparation work. We demolished all the plant rooms on the side, and then we used MUP access to get the access and do some preparation work on both sides. This is the temporary steel that goes in to support the strand jacks. So there was an awful lot of preparation work, and we stripped all the sides of the steels to actually get into a position where we could then cut the roof after some 80 years and lower it down. All the blue here identified as new temporary works, and the old colour steel is there. This is back propping down through the structure, so we had a cantilevered design, and in the basement then we strengthened where the trusses were going to land. So this is the inside the building and the roof, and you can see all these parts of the structure which were next part of the exhibition floor we had to demolish down. So this was all carried out in conjunction with the preparation work of the roof above. You can see these 7 trusses, main trusses. This is all the seating areas. Fairly traditional demolition internally. We did demolish it like a donut, so we did all work internally for dust and environmental reasons. So these are the cantilever, and you see the red there, there's a strand jack system. We dismantled the end gables because they were lightweight trusses and we didn't want to lift them. There's the bird again. This is the base of the actual trusses. So we did a trial lift with the strand jacks to make sure there was no problem in actually lifting these individually. Once we then lifted all 7 trusses, and then we carried out the cut of the actual trusses themselves. We left up 3 main trusses on each end just to give wind stability during all the preparation work. So they were the final things to come down. So it took us 11 hours to then lower the whole roof basically within the structure. So that's just under 1,500 tons of roof demolished down straight in. These are the strand jack systems. That's the major truss there. So you'll see here now that's where the actual truss started at the top, and it's just going straight down when all the demolition below was carried out. These end ones here, again, are lateral stability, so we had strand jacks at the 4 ends. So we actually lowered this whole roof 25 metres, which we could then demolish a lot safer because it was riveted angles and sections. It would come to part very easy. This saved many hours of working at height. So that's the whole roof lowered down now, and then we could process it pretty conventionally. All right, so this is once we got the roof down, the rest of the structure was around here. This is the roof gone here. So basically we had a main structure was 15 by 15 metre grid with secondary and tertiary beams, leaving sort of 5 metre, 2 spanning slabs. So basically all of this structure, although different angles and different configurations, that was the principle of the structure. The very large spanning big beams and big columns. So this is just various sections of demolition. In this case, we were cutting and lifting beam and column sections, traditional demolition, use of water jets to keep the control down, and conventional reduction of beams. You get an idea of the reinforcement that's coming out of these steel connections or the concrete connections. This is a picture of the old construction, and we're just trying to show you, I can't see it very well there, that's the actual tunnel. So when we come down, so the next stage of the job was get it down to ground floor level, and the next problem was taking the ground floor down with the main tunnels below.
Okay, so now we've reached the ground floor, we have a further challenge, which, as you can see here, are the tunnels. So 2 of the tunnels actually came right up into the basement, just below the ground floor slab, and 2 of them, depending where you're on section, were just in or just under the basement slab. So you can see here, this is what is known as a large portal beam spanning over the top of the tunnel. So in here is your mum, your dad and sister going about their daily lives. So we designed a protection system that would allow to take the load of a failed slab or beam, which is a high density polystyrene system. And we then divided the site up into green areas which had no impact on the tunnel, and we could demolish without the protection using traditional methods, and the amber and red where we were adjacent or over the tunnels and had a different beam configuration, and the protection and a detailed sequence was required. So this is just the green area, and then here this is the detail of the sequence in which each of the beams had to be removed because they would be taking some support from each other. So that's a 3D representation showing a different colour of the beams and the tunnel below. So there's the tunnel, protection placed, and then they will then removed in that colour coordinated sequence, removing the slab first. The sequence of the slab removal had to be very carefully thought out, so we didn't remove a bay that meant we couldn't site the machine somewhere to carry out the further demolition. So as you can see here, we colour coded and actually wrote the colours on the beams. We actually had to write the colour because one of our supervisors was colour blind. We're now at ground floor. So this is the demolition, getting down to ground floor level. So Earl's Court 1 and Earl's Court 2 actually started at the same time, but the programme for the demolition of Earl's Court 1 was 6 months longer due to the asbestos removal required and the extent of temporary works required to remove the roof.
This was traditional floor by floor, and we had 20-ton machines on the floors because we did floor loading testing and proved that they could take them loads.
Running short time.
Right, just quickly, we go through Earl's Court demolition. This was where we removed Bridge 19. That's the West London line, which runs all the way through one side of the structure. The encapsulating scaffold was all put up under possession works on both ends, and then we stripped out the internal. Right, so I'll go back to the actual structure itself. Over the West London line is 100 metres wide by 200 metres long. It has large barrel vault clear span roof structure, and the bottom section is a steel deck. There's steel beams for 2.2 girders over the rail. Let's track down here. And the actual is a sandwich construction. So one of the challenges was this is where the rail, so we left this slab section over the top of the rail. We had to strengthen this because obviously it was working as a plate platform, and we made it a narrow structure. So we put strengthening works in before we did the work, and we put protective screens either side of the job here and here, so as we could demolish these sides in what they call a rail or a highway environment in normal hours. This is a picture from that tall building adjacent, so it's giving you an idea of the roof. And this was just profile metal decking with insulation. These are the trusses underneath, the curved trusses, which are approximately 2.4 square in section, and they're about 10 metre centres. The actual gables gave us a bit of a challenge. in the fact that how they were constructed and how we were going to dismantle them, because they were actually supported by a minimum of 3 trusses internally. So we had to come up with a design solution to take these down. All of this is, the engineering had to go through Network Rail and LUL and had to be what they call Cat 3 check, which is an independent check. So our engineers designed it in conjunction with our demolition team, and then based that went off to an independent check. This is a section, we built these purpose-built cradles that actually sat on the main trusses and travelled up and down, and we just cut the sheeting and dropped it into a controlled area below. So you'll see, and this is the main trusses then left just spanning. View from inside, so this is the old exhibition floor. We then used a 500-ton crane, so this is 2 floors high, so this was all back-propped engineering with basement foundations. Basically supported the ends of the trusses, cut them and then lowered them down for processing. And we checked how they were built, and also this cantilever section would stay stable in its own right. So then once it was on the ground, fairly traditional, just shear up the trusses. They'd be gone in 2 or 3 hours. You can see we're progressively working on. These are the last 3 trusses that had to stay in place until we demolished the whole gable, and then we could lift down the trusses. Oh, okay. This is just a progressive demolition. There's the 3 trusses. You gonna flick? This is the actual exhibition floor being started now. So this was a steel frame, crinkly tin concrete slabs. We basically demolished it internally, maintaining the protection around the perimeter of the buildings and to the rail.
Should we skip this?
Yeah.
Just coming to the end, but the next stage that we're entering now is the removal of the portal beams. So over the tops of the tunnels to take the load of the structure, these portal beams were constructed. So there's a portal there, the district line below. There's 61 of these beams, varying in weight from roughly 80 tonnes up to 1,500 tonnes. So that's construction of a 1,500 tonne beam. It's about just over 30 metres long. There you can see the beam. Tunnel here, there's another tunnel just under the slab. And so the solution we've come up with to remove these beams is we're having the largest lift capacity crane in the world come to site. That's arriving just over a month's time, and this crane can lift out each of those beams as a single lift. So that's where the crane normally lives on petrochem type sites. And it has a 4,000 tonne ballast. Move around on the hydraulic skid tracks. There's different winch configurations. We've got this one, the 602,000 tonne winch. I've just flicked through this. So we've now exposed these portal beams ready for lifting. There'd be wire sawing to separate the beams from their column positions and temporary works to temporarily restrain them. All the works have to be done at night when the railway's shut, so we've got a 4-hour window to remove them over here. So this is the site currently, building the mat. So the crane would be sited here. And this is just the current progress of the works in the programme. And so the 61 beams will be removed from February next year with agreement with London Underground and arranging access with them for when we can actually carry out these works. Is very complicated, and this is just a schematic representation of the various tunnels and various spreader lengths so that we're trying to coordinate so that we can minimise the disruption to the rail and maximise the efficiency of the crane. This is the crawlers to erect it, which are large in their own right. Delivery of the crane is standard shipping containers. I'm sort of run out of time now, and then we process them in a traditional fashion using a combination of breakers and explosives. Any questions?
Well, thank you, guys. Dave and Jim, thank you. The only thing I can ask myself is, how do you bid a job like that? That's a GMP of the entire United States in one shot.
7 years ago, we entered a bid between 2 contractors who they thought had the ability to be principal contractor, so the main contractor effectively. We had 8 weeks to do a bid together, and then we won that, and we went to a pre-construction stage for a year to 2 years
to develop all the methodology, get the engineering carried out, agree all the processes. And so in that, we develop the methodology, the sequence, the resources, because largely it's a resource bid as against, you couldn't do it as a square meterage. And in that was obviously come out the challenges in terms of rail compliance, which is all about rail protection all the way through.
That's amazing. Do we have any questions from the audience?
Yeah, I was just going to say that's very, very impressive. How much did the overall project cost?
The first phase of it till the portal beams was just under £40 million. With the portal beams now, we're up to £75 million.
Wow. Are there any other questions? Is everybody's jaw still dropped?
I'm glad the client's not here, though.
Oh, we got a question back there, right behind you. Unless you want, do you have one, Murray?
The crane which you showed in one of the last slides, what's the capacity of the crane? What's the size?
The crane, depending on how it's configured, it's the moment arm that defines its capacity. So in its biggest radius, it can have up to 100-meter diameter track, and using strand jacks, it can then lift 5,000 tons. In the configuration we have it, which is on a 70-meter diameter, with strand jacks, it could lift 4,000 tons. But because time is of the essence, with the limited time to remove the beams over the tunnels, we're using a fast winch system, which means we've only got a capacity of 2,000 tons.
Only 2,000.
Yeah.
Just out of interest, the base of that crane is 80,000 tons, of which we've reprocessed the concrete on site and reusing that in this operation. It's 2 meters deep, the actual crane platform.
It's the most amazing thing I've ever seen. Are there any other questions from the audience? If not, Dave and Jim, thank you so much. That was amazing.
Thank you.